Hello friends, so let's continue with the next topic of the first unit, power switching devices of the subject power electronics, which is in fourth semester of GTU. Today we are going to discuss quickly the triggering techniques of SCR. So what is triggering? Triggering is nothing but the turning on of a device from off state. So when we try to switch the SCR on, we call it triggering of the SCR. Now look at the circuit. SCR is used as a switch in this configuration. So this is the forward blocking mode when the anode is supplied with the positive supply over here, cathode is negative, and you look at the construction, it's a PN. So when anode is positive with respect to cathode, junction J1 and junction J3 are already forward bias. The only junction J2 is reverse bias, and that is the blocking the forward flow of the current. So what methods are used so that this junction J2 is broken and the flow of current starts? Now, you know, when a thyristor is turned on, when you with some method. Suppose I break this junction J2 and the forward current anode to cathode is more than a certain minimum value known as a latching current, then only we say the formal or official or proper turn on of a SCR is there. So things are to be remembered. For the SCR to turn on, the junction J2 should break, the reverse bias should get vanished, and the forward current should start, and the value of it should be more than the latching current, right? So now let's see what are the methods for doing or achieving this. The different methods which are there in theory are forward voltage triggering, gate triggering, dV by dt triggering, light triggering, and temperature triggering, right? We are going to discuss all these methods in very brief, but the method number 2, gate triggering, is actually used in practice. The other methods are there on paper, but they are not used much, right? So what is forward voltage triggering? We know when a thyristor is in a forward blocking mode, so at that time, if the forward voltage is more than the breakdown voltage, then the breakdown of junction J2 will take place, because ultimately it is a reverse bias junction. And if a voltage sufficiently more than the breakdown voltage is applied, that junction is going to break down and forward conduction starts. So if that method is applied by applying large forward voltage, so this is the method where you don't use gate, you don't give any supply to gate, and forward voltage of very large magnitude is applied, which is more than the breakdown voltage, right? So this is this way, if we go for the starting or turning on, it is called the forward voltage triggering. Of course, this is not a practicable way. Just for turning on, I cannot give that large voltage. So this method is not practically used. It can destroy the device. So that is not used in practice. But yeah, theoretically, it is possible to turn it on. That's why it is listed in the triggering method. The second method is gate triggering. Here, the positive voltage or gate pulse is applied, where gate is made positive with respect to cathode for a certain duration of time. This is most commonly used method, and there are different varieties of gate triggering, which we are going to discuss in our subsequent videos. We shall discuss this type in detail in later section. Here, junction J2 breaks because of the gate pulse or forward bias. It injects the lot of charge carriers, and because of that, that depletion layer breaks, and the thyristor SCR gets turned on. Gate pulse to be applied for the time duration for which the forward current is more than the latched current, right? So it's called turn on time. So the gate pulse should be more than the turn on time of the SCR. If gate pulse is applied for a very short duration, then also SCR will fail to turn on. So if a sufficiently large time gate pulse is applied, which is more than the turn on time of the SCR, then the thyristor will get turned on. What is the requirement for thyristor to get turned on? It should be in a forward blocking mode. That is, anode should be positive, cathode should be negative. And with gate pulse, the junction J2 breaks, forward current starts, and when the forward current is more than latching current, the SCR is turned on. The time required for this whole process to complete is called turn on time of the SCR, and the gate pulse duration must be more than the turn on time of the SCR. So we shall discuss gate triggering in detail in the next videos, right? Now, of course, gate pulses can be removed after turning on of the SCR. Continuous gate pulse is not required, also not desirable. Now, the dV by dt triggering. So, when it is in a forward blocking mode, when anode and cathode are positive and negative respectively, junction J1, J2 are forward bias, and J1, J3, sorry, it should be J3 over here. Junction J1 and J3 are reverse bias, forward bias, and the junction J2 is reverse bias, right? So this is the situation where two conductors are separated by insulator, right? J1 and J3 are behaving as a conductor because they are forward bias, and J2 in between is a reverse bias, so it is acting as an insulator. So this is nothing but it's forming a capacitor. Now we know the principle of capacitor, that Q is equal to C V, and so if you differentiate, you get the forward current which is proportional to dV by dt. So if the rate of change of forward voltage, not the magnitude, the rate of application of forward voltage is large, then the forward current is also going to be large. It is similar to the current drawn by a capacitor. And if this current is larger than the latching current of the SCR, then obviously the SCR turns on. So this method, if it is used, it is called dV by dt triggering. So here, high dV by dt voltage is applied to turn it on. Of course, this method is also not advisable because high dV by dt also can damage. So if on paper or theoretical it is all right, but this method is also not used in practice because high dV by dt can destroy the device, right? Now, light triggering. So there are certain special type of SCR known as a light activated SCR, where a niche or a slot like this is there, where a light, if it is impacted, it is targeted on that slot, then it generates a lot of charge carrier and it breaks the junction J2, and ultimately this results into turn on of SCR. So this is possible only in a special type of light activated SCR. These rays of light are allowed to strike the junction of the thyristor. This results in an increase of the number of the electron hole pair, and thyristor may be turned on, right? Now, the last method is called temperature or thermal triggering. So what do we know? When a junction J2 is reverse bias, a small leakage current is flowing, right? That we already know it is there in case of diode also when it is reverse bias. Now this leakage current is a function of temperature. So if we increase the temperature, the leakage current increases. So is it possible that if by increasing temperature, the leakage current is so much increased so that it is beyond the latching current, and so that thyristor gets turned on? So this method, if it is used, it is called temperature triggering. So with sufficiently large leakage current, J2 breaks and SCR gets turned on. So temperature is used to increase leakage current of the reverse bias junction J2, and that is used to break the junction J2 and to turn on the SCR. Of course, this is not a preferred method as it can cause thermal runaway and damage to the device. So these are the methods of turning on the SCR. Actual methods are used with the gate triggering, and what different gate triggering methods are there that we are going to discuss in our next video, right? So that's all in this video. I hope you have understood in concept how a SCR is turned on and what are the different methods possible on paper and what is a popular or commonly used method, right? So that's all in this video. Thank you.